Alright, so in this video we're going to talk about the Pons. And what are we going to talk about here? Well, in the last video with the medulla, we broke the medulla into 3 different regions, right? We had a rostral part, then we had a sensory desiccation, and then we had a pyramidal desiccation. Okay, so there was 3 hard parts. Now, since we're ascending upwards, we know that there's a lot of overlap. Fortunately for us, the Pons only has 2 different regions. We have a superior and an inferior part. Now, I'm going to tell you guys in 1 minute where the superior part starts and where the inferior part starts, like on how we can differentiate top and bottom. But first, one quick thing. For this video, I have all of our structures right down the middle because most of them are on each side, right? So I'm just going to point from here. I'm going to tell you this, and then I'm going to move over here quick and tell you where it is in this region. Now, if you click in the link, or I guess it's the description box, I typed up a list, and the list was all of the structures we've learned in the medulla, and now it's all of the structures in the Pons. So it's a cumulative list. What does this mean? Okay, so for example, right, I'm talking about the medial meniscus. The medial meniscus, we remember it's in the medulla. However, it's also going to be in the Pons. So instead of numbering these guys 1 through 22-ish, right, I started off at number 36. Why? Because the last structure that I have in the medulla video was the olives, and it was number 35. So I'm going to start at number 30. Actually, I think I started at 38 for this video, and I'll explain why. But I'm just continuing down the order, and when there's an overlap, I'm going to go back to that overlap numbers. So like medial meniscus, like I just said, it's number 12. It's not number 12 in our structure in the Pons list, it's number 12 in our overall list, because a lot of the structures are going to keep overlapping as we ascend up the brainstem. Now, there's a lot of overlap. 12, number 13. If I look down, we have number 3, number 28, etc. So I think, in my opinion, I think it's really, really important to understand the medulla first, know all of those structures, and then go into the Pons. If you go into the Pons, it's going to be much more it's going to be a lot easier understanding what goes where and why things do what they're supposed to do. Okay, so now I'm just going to mention quickly how we could differentiate between the superior and inferior part, and we'll start the video. Okay, so real quick, right? 2 different regions, right? I said we have a trigeminal part and we have I shouldn't have said that. We have a superior part and an inferior part, right? 2 different parts. Now, the trigeminal part, I gave it away, is in the name. So, before I talk about that, what do we have? I just draw the little end of the spinal cord, right? Down here's our spinal cord. It ends around where? We said L1, L2-ish, correct? That vertebrae? Okay, so we ascend upwards, what do we get to? This region right here, our first little bump, I guess you could call it, is our medulla. Our medulla what? Medulla oblongata. Okay, we just spoke about this guy. We spoke about all the structures that go through him, etc. Now, if you ascend upwards, we're in what region? This region right here is the Pons. Okay, now, like the medulla oblongata, well, not just like the medulla oblongata, I'm going to make them a little bit bigger. Remember, for the medulla oblongata, we had 3 different regions. The most superior region was the Pons medulla junction. Why was it the Pons medulla junction? Because it separated the Pons from the medulla. That was the superior region. The middle region was the sensory desiccation, and then the most inferior region was the pyramidal desiccation. Now, for the Pons, instead of 3 layers, we just have 2 layers. Not bad. So, the most superior region is going to be the trigeminal level. Why is it called the trigeminal level? Because it's at the trigeminal nuclei. So wherever the trigeminal nucleus, the trigeminal nerve, right, where this structure is, that's going to be our most superior level of the Pons. Good. Now, the inferior level, right, so the bottom level, you could say, is known as it's located at the facial abducens nerve. Why? Because this is where the facial and the abducens nerve is. So you can say the bottom level, or the most inferior level, is connected to where? The Pons medulla junction. Okay, so we have facial abducens nerve, right? Bottom layer, Pons medulla junction, superior portion of our medulla. Boom, they're connected. Now, superior to that, trigeminal level. Good. The two layers are not too bad. Just for the fun of it, I guess, we could say this is the midbrain because we know that's higher, right? What is posterior to these structures? I should have drawn it a little bigger. Is the cerebellum. Now, one quick thing to mention, what did we talk about? What connects to the cerebellum for all three of these structures? Well, in the medulla, we have the inferior cerebellar peduncles. In the pons, we have the middle cerebellar peduncles. And then in the midbrain, we're going to have the superior cerebellar peduncles. Fine. A key thing we have to remember, not only do other structures that come from the medulla, right, ascend up into these different regions, for example, the pons, the midbrain, etc., but they share. What are they going to share? So the medulla oblongata, and the pons are not only going to be separated by the middle cerebellar peduncle and inferior cerebellar peduncle. The inferior cerebellar peduncle, kind of, like just a small part of it, I'll show you where later on in the video, but a small part of it is located in the medulla oblongata and in the inferior, so the bottom region of the pons. Well, what was the bottom region of the pons called? The facial abducens nerve, that level. Okay, not too bad. This video is really not as long or as hard to comprehend as the medulla one, so we'll just get into it right now. Okay, so now, what did I say? We spoke about superior level, inferior level, right? Two segments, right? Right down the middle, split it in half, whatever. You know, you have a top and a bottom, base. Okay, now, we have a top and a bottom, which came from where? We just said it. Here's our little brain stem. Here's the pons, split it in half, superior, inferior. Now, we have a top layer and a bottom layer, right? That's slice. What else we have to separate is two different regions. We have a dorsal segment and a ventral segment. What are the differences? We know dorsal is the same as posterior, so back, and we know ventral is the same as anterior, front, right? So just like the medulla, you take this guy, you rotate him like flat, and that's how you're going to see front and back. Would be ideal if I was able to draw the board like looking this way and you guys could see back and front, but this is what we have, a vertical board. So this is going to be the dorsal segment, this is going to be the ventral segment. Posterior, anterior, same thing. Now, an important thing to know, this is why I told you I skipped 36 and 37 on the structure list, or when I spoke about it, is because I have them for the two different segments. Number 36 is known as the ventral or the basilar part, it's the base. So the bottom part, the anterior region, is known as the basilar segment. Okay, so from right here, all the way down, is known as the basilar segment. Now, if you go from this region, about maybe in the middle, a little bit more anteriorly, but about in the middle, and you ascend back, we have the tegmentum. Okay, so the tegmentum is another section. So the dorsal side is tegmentum, the bottom side is the basilar. Okay, not too bad. And this is not just for this trigeminal layer, this is also for the facial and abducens layer. Same thing. The posterior or the dorsal part is the tegmentum. The ventral or the anterior part is the basilar, the base. Okay, not too bad. Now, we know that. I'm going to start off strictly talking about the trigeminal layer, but you know, just like in the medulla videos, I'm going to jump back and forth, right? I'm too hyper, I can't sit still. So 38. First one is the Pontine Nuclei. This guy is like the Pontine bulbar body. What does he do in particular? He receives some innervation from the descending motor tracts. Okay, we spoke about descending motor tracts. Now, which motor tracts does he receive them from? Mainly from the cortex. Okay, comes from the cortex and he sends it to the contralateral. So contralateral, what? The contralateral cerebellar peduncles. Which part? Well, if we're in the pons, we're mainly talking about the middle cerebellar peduncles. Now, real quick, here's number 38, right? 38 was the Pontine Nuclei. Where's he getting his information from? Well, I said, if you remember, we have the cortex, right? Cortex, we have two of them. Cortex. And it's called corticospinal tract. Why? Cortico, cortex to the where? Spinal cord. So it descends down. So you can get his information from the cortex, and it's going to pass it through what? Remember this thing? These triangles? Let's see if I can draw a 3D. Okay. These triangles are called the Crestery. They pass through the posterior limb, of the crus cerebri, and they descend down, right? When they descend down, some of their information kind of like separates, right? It splits. Where does it split to? So if you take this part right here, right, and just hypotheticize it, these fibers, and just take these fibers and put them right here. I know it's not passing through all of these, just I want to show it like in a cross-sectional view. Some of the fibers split, and they're going to target these Pontine nuclei. After they split and they keep descending down, they're going to come back together. When they come back together, then they're going to travel through the corticospinal tract. And what are they going to target? Specifically, our cross-sectional view of our spinal cord. They go down through the lateral white column. And what do they target? Anterior motor horn. Well, anterior gray horn, which is motor supply. And it releases alpha and gamma motor neurons, right? This is for contracting the muscle. Alpha, remember, is extrafusal fibers for motor contraction. And gamma is for what? Intrafusal fibers, particularly nuclear chain and nuclear bag fibers, which is for stretch and tension. We spoke about this 100 times. Just I wanted to make sure that we knew where are some of these Pontine nuclei getting their innervation from. Now, say the ones on the right side and the ones on the left side, right? Left, right side of my body. The ones on the right side get the supply, and what do? They're going to send the information where? Contralateral. So the ones on the right side, so this is the right, this is the left, contralaterally send their information through where? The middle cerebellar peduncles. So as you see, number 39 is the middle cerebellar peduncles. When it passes through the middle cerebellar peduncles, where is it going to? We know this. Whenever they pass through a peduncle, or a cerebellar peduncle particularly, it's going to the cerebellum. Cerebellum, we know what this is used for. Eyes closed, extend my arm, proprioception. I know where my hand is in space. I know where my arm is when my eyes are closed, right? You know where your body is. Okay, how do these fibers, or how does this Pontine nucleus send the signal through the middle cerebellar peduncles? We have a fiber. What fiber is that? This is going to be our pontocerebellar fibers. Makes sense. Pontine nucleus, cerebellum, right, out here, so pontocerebellar fibers. Now, quick, the right side goes where? To the left, contralateral. Where is the left side going? The right, contralateral. Makes sense, they crisscross. Okay, so this middle cerebellar peduncle connects the cerebellum to the pons. Well, not to the pons, it's at the pons area. We're talking about the pons right here. Where would the inferior cerebellar peduncle be? We just spoke about it. In the medulla, and the superior cerebellar peduncle, the midbrain. So our middle cerebellar peduncle is in our pons. Okay, so it goes through the pons and it connects to where? The cerebellum. Fine, we know this. Next structure on the list, right? Actually, real quick, this is in the trigeminal level. Where else is he going to be? He's going to be in the facial and abducens level, right down here. It is the same exact motion. The same exact thing is occurring. We go right to left, left to right. Contralateral crisscross into where? The middle cerebellar peduncles, right here. Middle cerebellar peduncles. Good. Okay. Number 41 now is the trapezoid body. Why do you think it's even called a trapezoid body? Well, it looks like a trapezoid. The structure of a trapezoid is like this. And where does this get its name from? Or why is he looking like a trapezoid body? It's because he's getting contralateral fibers. So these contralateral fibers are going to come and make a crisscross. When they make a crisscross, they're going to form a trapezoid. Now, this crisscross is coming from the crossing of the cochlear fibers from the cochlear nuclei. Where is the cochlear nuclei located? Okay, we'll talk about him in a second, but he's mainly in the facial and the abducens region. So you're like, Joe, why is the trapezoid only in the facial abducens? Why is the trapezoid in both regions if our nuclei is in the facial abducens and in the trigeminal region? Because it's not only coming from these fibers. It's also coming from something that we know is called the acoustic striae. The acoustic striae helps with auditory control, so it helps with hearing. Now, where do these crossing of the cochlear fibers, right? They come from the cochlear nuclei And when they cross the trapezoid body, they ascend. They ascend upwards. What are these guys going to ascend into? Well, when they ascend, they're going to come into structure number 43, which I wrote right here. Number 43 is called the lateral meniscus. Okay, so they're going to cross over and they're going to go into the lateral meniscus. Now, I drew him way up here, but I probably shouldn't have. I'll show you why I shouldn't have right now. He should be over here. Ready? We have 4 different regions. We have the medial, trigeminal, spinal, and lateral meniscus. Now, what are these things and why are they even used? Well, number 12, if you remember from the medulla video, number 12 is the medial meniscus. What does he do? He's sensory information from the dorsal column. I'm not doing this structure again, we've done them 100 times, but this tract is the dorsal column medial meniscus tract. He sends ascending fibers, which is what? Fine touch, proprioception, and vibrations through the dorsal column. Fine. He's on both sides, right? We have him where? In the trigeminal part. Where else is he located? The facial and the abducens region. Why? Because these fibers are coming from where? They're coming from the spinal cord all the way up to the brain. So if he's passing through what? He's passing through the medulla. Then he's passing through all 3 levels of the medulla, through the medulla. Then he's passing through the inferior level of the pons, and the superior level of the pons. And then we'll talk about what happens when he gets to the midbrain in the next video. Fine. So that's the medial meniscus. Now, the trigeminal meniscus. Okay, where do you think the trigeminal meniscus is going to be? I have him as number 42. What did we say? This is the trigeminal region. This is the facial and the abducens region. So, do you think the trigeminal meniscus is going to be located here? No. What is going to be located in the facial abducens region? Well, you're going to have tracts coming up, right? Particularly our spinal tract. We talked about the spinal tract, and it gets innervation from the V1, V2 branches of where? Trigeminal nerve. When these 3 branches pass through the trigeminal tract, they ascend upwards, and what do they form? They form our trigeminal meniscus, which is located, boom, right here in the trigeminal region of our pons. This is why it's called the trigeminal region of the pons. Fine. This was used for what? Touch, pain, temperature, and pressure, and proprioceptors, particularly for our face. We have to remember trigeminal nerve is cranial nerve 5 for the face. What were the 3 branches of the trigeminal nerve? V1, oculomotor. V2, maxillary. V3, mandibular. Fine. Now, that's a little bit more lateral. We proceed laterally again, and we have the spinal meniscus. Spinal meniscus. Okay, he's coming from the spinal cord, and he's traveling upwards. So he's going to be in both trigeminal level, facial abducens level. What other level is he going to be in? We know the medulla. Inferior, middle, superior regions, because he's coming from the spinal cord upwards. So fine, this is another overlap. That's why I have him as number 13. We saw him in the medulla video. He's sensory information, and he's used for pain, temperature, pressure, crude touch from where? Well, it's these senses from the neck down. So it's receiving senses from the neck down. So the neck down, I'm sorry. Now, number 43 is the one that I said I'm going to get back to right now, where I kind of not misdrew, but like drew it too high up. This is the lateral meniscus, right? He's going to be in both the trigeminal region, and he's going to be in the facial and the abducens region. Why? Okay, so I said these fibers, right? They form from the crossover of fibers from the trapezoid body for hearing, from the cochlea. Now, up here, right? The crossover already takes place. So we don't have to worry about the crossover. However, if the crossover already takes place, are we going to get rid of the fibers? No. Why are we going to get rid of the fibers? Because these fibers are traveling from the trapezoid body upward, right? They're moving upward. Now, why would it make sense for this lateral meniscus that I drew up here not to be here? Well, he's really going to be down here. He's going to be lateral to where? Number 13. Lateral to number 13. What was number 13? I just said the spinal meniscus. However, I didn't want to draw them over these 4 different fibers, which we're going to talk about, because I don't want things to get too confusing. So I kind of just drew him up here, and then I was going to erase it to show you guys. But he really is supposed to be right over here. So the trapezoid body is going to send the fibers right into that region. What region? Lateral meniscus. Good. Okay, we covered those. And what is the lateral meniscus used for? Well, it's for hearing. Where does it come from? The ventral cochlear, right? The ventral cochlear nuclei. Not the dorsal one, the ventral one. We spoke about the difference between dorsal and ventral. I'm going to go over it in a minute, but just remember that quick concept. Now, number 44, we ascend a little bit more laterally, right? This is going to be our ascending fibers from the ventral spinal cerebellar tract. He's coming from the spinal cord and he's sending up to the cerebellum, right? This is for proprioception as well. Okay, if he's ascending to the cerebellum, where is he exiting? Or how is he exiting? He's going to exit through what tract? He's going to exit through our inferior or middle cerebellar peduncles. Primarily, it's going to be the middle cerebellar peduncles for the Pons, but I'll explain why I said maybe the inferior and the middle cerebellar peduncles when I get more to the facial level of the abducens. Okay, now, this should be a repeat for you guys. Rubrospinal tract, descending, right? Rubrospinal was descending motors to the flexors, right, of our upper limb. So it's for flexor control of the upper limb. And where is he located? Well, he's in both the trigeminal and the facial abducens level. Why is he in both of these levels? Because he's coming from where? He's coming from the top of the brain, maybe the cortex, sending it down. He's got to pass the midbrain. He's got to pass the medulla. No, he's got to pass the midbrain. He's got to pass the pons. He's got to pass the medulla, then proceed into the spinal cord. So he's got to be in both levels. What else has to be in both levels? Our tectospinal tract and our medial longitudinal fasciculus. Why? The tectospinal tract is, again, descending information from where? This time he's descending from the tectum. Okay. And what was the tectum made up of? The tectum was made up of superior and inferior colliculus, or the superior inferior colliculus. Now, what was this even used for? We remember, superior was for visual info, and inferior was for auditory. Okay. And it's mainly taking these motor neurons from the head and the neck and it's putting it to the eyes. Okay. Well, the eyes and the ears, correct? It's superior colliculus down to the eyes and the ears. We know what is functioning. Fine. The medial longitudinal fasciculus, right? Takes information mainly from cranial nerve 6, which is our abducens nerve, and he connects to what? He connects to the 3rd, 4th, and 6th cranial nerve. What were those? Okay, it's the oculomotor and the trochlear nerve, right? They follow the ascending tract, so they travel up through the body. And what are they used for? Well, we have to remember 3, 4, and 6 make our eyes do tricks. They're used for our eyes. Now, that covers the first half of these structures. It's really not too bad. The Pons is really not that bad. Now, number 45, right? Number 45 and 46. I have written trigeminal motor nucleus and trigeminal sensory nucleus. Where do you think they're going to be located? Are they going to be in the facial and the abducens level? No. Why not? Because it says literally in the name trigeminal. So it's going to be in the trigeminal level of the Pons. Now, what are the differences? If you see 45 and 46, right? They travel out of the Pons, right? They travel down. I didn't want to make it too messy, so I didn't really draw it. But they travel down on both sides. They travel down. I'll draw it lightly. They travel down, and what do? So the motor nucleus, right? He has his fibers are called special visceral efferent with an E. Efferent fibers, correct? And what do these guys do? Well, they're used for our muscles of mastication. Wow. So what can they be? The muscles of mastication is our chewing muscles. So, cranial nerve what? Cranial nerve 5, so the trigeminal nerve, but what branch in particular? V3. V3 was our motor supply from our mandible. So our mandibular branch of the trigeminal nerve, V3. Now, what about the trigeminal sensory nucleus? In a lot of videos I talked about this crazy thing called the Pontine Nucleus, right? Well, all the Pontine Nucleus is the trigeminal sensory nucleus. It's another name. Another name for this is called the central or principal Pontine Nucleus, right? And it's from trigeminal nerve 5. all that is, trigeminal central nucleus and central principal Pontine nucleus, same thing, just a different name. And what do? Well, if the motor does the muscles for chewing, the sensory does our sensations from the face. What sensations? V1 branch and V2 branch. V1 is for the eye, V2 is for the maxilla region, right? So from here up would be sensations, and from here below, sensations for where? The maxilla region. That's the mandible. This is the maxilla. Okay, not too bad. Not too bad at all. The fourth ventricle is next. We spoke about the fourth ventricle in what video? In the cerebrospinal fluid and the spinal tract video. I'm pretty sure it's video 1 in the neuro series. However, where did he get his supply from? He got his supply, if you guys remember, from the third ventricle first off, right? And when it went from the third ventricle, it passed through something. What did it pass through? Well, it passed through the cerebral, I don't know if you could see that, but it passed through the cerebral aqueduct. Now, when it passed through the cerebral aqueduct, it went to the fourth ventricle. So it receives the fluid from the cerebral aqueduct and it goes to the what? The foramen lusca or the foramen meningi or the central canal. We spoke about that in that video. That's lateral, medial, or right down Broadway in the middle. Okay. Now you're like, why do I have that as 47 and then why do I have 48 right above it? Okay, 48 is known as the superior medullary vellum. All this guy is, very simple. He's a thin layer of tissue that separates the part of the superior cerebellar peduncles with the fourth ventricle. Whoa, why the superior cerebellar peduncles? Okay, what is above the trigeminal region? Above the trigeminal region is what? We're going to get to the medulla. Not the medulla, the midbrain. When we get to the midbrain, we're going to have a superior cerebellar peduncles. They're going to travel across. Now, 48 is the tissue, this layer right here, that separates these superior cerebellar peduncles from the midbrain with the fourth ventricle. That's all it is. Not too bad. Okay. So, now, 28, right? We've spoke about him a lot. Why is he 28? Well, if you go to the structure list again, facial nerve. That was in the structure list. Now, all I wrote was 4 parts. Okay, yeah, I know the facial nerve does not have 4 different branches, but for this particular video, or for the Pons region, I should say, there's 4 different regions that the facial nerve surrounds. Well, that's weird. Look, see the purple dots that I have around here? So these purple dots, right, they engulf 4 different structures. Well, these 4 structures are part of the facial nerve. Now, the 4 structures, luckily, we've already mentioned all of them. We already know what they all are, and what they all do. Now, let me just talk about it real quick. 28.1 is the first structure. He's the motor nucleus of cranial nerve 7. Okay? 28.2 is this, well, what does the motor nucleus of cranial nerve 7 do? Cranial nerve 7 is the facial nerve. Motor part of it is what? Muscles of facial expression, right? Smiling, frowning, wrinkling my forehead, which I really can't do. And these fibers, right, they come from where? If we think of embryology, I know this is way back, they come from the second pharyngeal arch. And what type of fibers are these? These are special, visceral, efferent fibers. Why do I keep saying efferent, or like E-F-F-E-R-E-N-T? Not afferent with an A, efferent with an A. Well, the efferent fibers, right, they're like sending things away from the brain, right? They're away, they're to something. What's the difference between efferent and afferent with an A? Afferent receives the info and brings it back. Efferent, like, distributes it. So these, since it's distributing info, are known as special visceral efferent fibers. That's the motor nucleus of cranial nerve 7. That's in this facial nerve, or in that structure that I said. Now, 28.2. He's a superior salivatory nucleus. He connects to the facial nerve. He's not branched off the facial nerve. But remember in the video, what did this guy do? The superior salivatory nucleus, he connects the facial nerve to where? The parasympathetic nervous system. Okay, and he's not special visceral efferent fibers. He's just known as general visceral efferent fibers. Okay, so you just need to know special comes from the second pharyngeal arch, and general just comes from where? facial nerve to the parasympathetic nervous system. Now, what is he mainly doing? Well, he's named the superior salivatory nucleus, so something to do with salivation. However, it's not just salivation. He also does lacrimation, salivation, and he also, you know when you have a runny nose, you have nasal fluid? He also aids in that fluid, right? The nasal fluid. Okay, not too bad. The next part is called the nucleus of Tract Solitarius. We've spoke about him a lot. He's used for taste receptors, right? So this taste receptors, think about taste buds, right? You taste something. Where's the information coming from? It's coming from your tongue to your brain. It's not coming from your brain to your tongue. It's not sending things away. So what type of fiber do you think it's going to be? It's not going to be efferent. It's going to be an afferent fiber with an A. A-F-F-E-R-E-N-T. So it's going to taste from the anterior 2/3 of the tongue, right? So the front 2/3 of my tongue, to the brain. So it's going to be known as special visceral afferent fibers. Afferent. Now, next one, 28.2, or 28.3, right? We saw him in the last video. Sensory fibers of the facial nerve. He's going to send these fibers to where? The spinal nucleus of cranial nerve 5. Okay, if he's sending these fibers to the nucleus of the cranial nerve 5, what is he going to do? Well, what is cranial nerve 5? Cranial nerve 5 is the trigeminal nerve. Trigeminal nerve has 3 different branches, right? He has V1, oculomotor, V2, maxillary, V3, mandibular. Now, when these fibers, right, they're sent, they're called general sensory afferent. General meaning whole side of the face, right? And sensory, because it's a sense, afferent to the brain. How are these fibers, for this tract specifically, going to the spinal nucleus of the cranial nerve 5? I'm going to talk about him right now. Okay, so you see this crazy diagram, right? So 28.1 was the motor nucleus of the cranial nerve. Okay, all of these fibers, they loop around number 27, which is the Abducens nerve. We talked about him. He was for what? The lateral rectus muscle of the eye. It helps our eyes, what? Abduct, go away. Now, I spoke to one of my teachers about this. The reason why they loop all the way around is like an evolutionary thing. So we started off as what? Like fish and stuff like that. We ascended into monkeys, into humans, whatever. Some of our structures that are in fish are not in humans. So I guess the body, when we evolved, went a certain way, and then we have this little loop-de-loop. Okay, now, 28.1, right? He takes the motor nucleus of cranial nerve 7, goes around the Abducens nerve, sends it out, right, to what? Motor regions for motor supply. Of where? Facial expression. Now, 28.2, superior salivatory nucleus. Same thing, wraps around the Abducens nerve, goes down, sends the solid supply to where? Lacrimation, salivation, nasal drips, etc. Number 3, nucleus of Tract Solitarius. Wraps around the Abducens nerve, shoots out, goes to where? The tongue. For what? Taste. This is the interesting one. Very, very interesting. I think it's pretty cool. 28.3, right? Our sensory fibers of our facial nerve. Facial nerve is trigeminal nerve what? Trigeminal nerve 7. No, not trigeminal nerve, I'm sorry. Facial nerve is cranial nerve 7. Okay. And he's going to send his fibers to where? I said the trigeminal nerve. How is he going to do this? Well, let's see. The spinal nucleus of cranial nerve 5 is his end target. Okay. 28.3, right? We start right over here. Sensory fibers of what? Of the facial nerve, cranial nerve 7. He comes around, wraps around the Abducens nerve, we said, descends down. He's going to descend down and he's going to target something. What is he targeting? We said general sensory afferent fibers. Okay. What are these? Where are these afferent fibers even located? Well, these afferent fibers are located in the external ear. So, I know this is not a good drawing, but this is my ear. He's going to go to the external ear and the tympanic membrane. Okay, so from the tympanic membrane, right? These fibers are going to say, okay, this is what we're stimulating. Now, the facial nerve is like, oh, I want to be a part of this tract. So now these fibers, right? These fibers are going to travel upwards. When they travel upwards, what are they going to hit? They're going to hit our number 14. We've spoke about 14 and 14.1 multiple times. 14 was our what? He was our spinal tract. Now, he was our spinal nucleus of cranial nerve 5. What was the spinal nucleus of cranial nerve 5 used for? Where is he even located? Mainly in the medulla. However, this is the inferior region, so it's in the medulla and into the pons. The spinal nucleus of cranial nerve 5 does what? He's going to send information to where? Our face. Now, 14.1 was the spinal tract. We know that they were connected. Just the main takeaway was number 28.3. The sensory fibers of the facial nerve sends the information down to the external ear or the tympanic membrane. The fibers come back around and they target where? The spinal nucleus of the cranial nerve. I spoke more about the spinal nucleus of cranial nerve 5, the trigeminal nerve, in what video? The medulla video. Fine. Now, I said the abducens nerve was next, right? This is cranial nerve 6. All he is motor function. And what does he do? I said the lateral rectus muscle of the eye. Okay, lateral rectus muscle of the eye. So if he's only doing one target, general sensory efferent, right? He's sending information to the eye, general sensory efferent, right? Motor, not to the brain. Now, whoa. What is number 4? We've seen him not so many times. We saw him in the medulla video. And in the medulla, what does he look like? He looks like this, right? And we have a superior, a medial, a lateral, and an inferior. Okay, not bad. This guy's the vestibulo nuclear complex. Okay, this complex was made of 4 different things. In the medulla, we mentioned he only used really the medial and the inferior part. Now, in the pons, however, since the pons is more superior, all it has in it is what? It has the superior region, the medial region, and the lateral. You can't see the inferior region in the pons. He's only in the medulla. So now, what does this guy do? Okay, well, he's mainly for the maintaining equilibrium, posture, head and neck position, and like clear vision of our eyes, right? If you move your head, how do we keep our eyes from like not getting blurry? This complex does it. Now, 4.1, I have the medial vestibular nuclei. 4.4 is the superior vestibular nuclei, and 4.5 is the lateral vestibular nuclei. We have 4 of them, right? But the only ones you can see is superior, medial, and lateral. You can't see the inferior one in the pons. Good, we're almost done. Number 5 and 5.1, we spoke about them already in this video and in the medulla video. This is the dorsal cochlear nuclei and the ventral cochlear nuclei. Okay, right over here. The dorsal cochlear nuclei, right? A little bit posterior. He sends his fibers straight up. He sends his fibers right up the body, right through the brainstem. What is different about the ventral cochlear nuclei? We just mentioned the trapezoid body. These cochlear nuclei contralaterally cross. Contralateral, crisscross. They help form the trapezoid body also with the acoustic striae. Now, when they crisscross, right, they ascend upwards, and they hit what? Gotta know this. The lateral meniscus. And what was the lateral meniscus used for? He was for hearing, right? He had other functions. We said there was a lot of tracts that target him, and specifically we said we had ascending tracts, 3 of them, that form to make this nucleus. That's in the tracts video. I don't have time to go through it right now, but just know the 3 tracts converse up. Also, the tract from where? The ventral cochlear nuclei, and they help form this lateral meniscus. Fine. Now, lateral meniscus, I'm gonna do my little overlap here. Like, we've already seen this structure. And what number is he? He's number 43. Okay, so these fibers are gonna ascend up into 43 on both sides. Now, the inferior cerebellar nucleus, right? Where is he from? We remember him from the medulla. Fibers travel up. He's in between 5 and 6. Or no, 5 and 5.1. Why? So he's in between the dorsal cochlear nuclei and the ventral cochlear nuclei. And what fibers go through him? Like I said, there were so many different tracts we spoke about that went from the spinal cord all the way up. They ascended upwards into the cerebellum through this inferior cerebellar pedunculus. We said he's mainly in where? Let's draw the brainstem one more time. It's a bad picture, but medulla, pons, midbrain. This region right here, on both sides, is the inferior cerebellar peduncles. Inferior. This region, the pons, has the middle cerebellar peduncles, and the midbrain has the superior cerebellar peduncles. However, the inferior cerebellar peduncles is right near what? The pons medullar junction. So he's in both the medulla and a little bit on the inferior side of the pons. What was the inferior side of the pons? The facial and abducens layer. Now, we're right there. We're almost done. The facial, let's do number 50. Number 50 is right over here, right? What is number 50? Number 50 is the superior olivary nuclei, or nucleus, right? He's in this region right here. He's used for a lot of different structures, which we spoke about, but we'll talk about it more later in a later video. He's mainly used for intensity, right, and velocity of timing from the auditory sensations. Okay, so you know what? What do we know? We could time things with the way our ears sound, right? There's so many different examples that I can relate to sports. Like you could say, you hit a ball, right? And you could like figure out how long it takes for the ball to travel over the fence. Or if someone like shoots a basketball and you hear a psh, you could kind of like sense or like hear how long it takes something to travel. This is a main supply from the superior olivary nucleus. Fine. Last one I skipped, 49, is the facial colliculus space. Why did I skip him? I don't know. But 47, right? We said 47 was what? 47 was the fourth ventricle, and he was in both the trigeminal region and in the facial and the abducens region. Now, when he's in the facial and the abducens region, what's different, right? Well, we have the facial nerve doing these fibers, right? The fibers are going around the abducens. Now, since these fibers like are really tight and like profound and like large, they need space. They need space. If they don't have space, they're going to run into this fourth ventricle. A lot of problems can happen here. So someone's going to give him a little bit of space. That's our facial colliculus space. Oh, makes sense. Facial colliculus space coming for the facial nerve, the four different things. And it's just number 49, right? It just gives us a little buffer from the fourth ventricle into this facial colliculus, or into the facial nerve supply. Now, what else could we talk about? Honestly, I think nothing. Like that covered everything for the pons. If there's anything else you guys want me to go through, just let me know in the comments. I'll post some practice questions later, and the next video, I'm going to speak about different lesions of the pons. So just like the medulla, we spoke about the lesions of the pons after. I'm going to speak about different lesions of the. We spoke about different lesions of the medulla after. In this video, I'm going to speak about the next video. I'm going to speak about different lesions of the pons. All right, so that's everything, and hope this helped.